All right, so now I'm going to show you some of the aspects of SAS programming. So in here, I'm going to open up Sas Studio and just show you some basics of what SAS can do in terms of statistics and drawing graphs. This with SAS with Python, Python is a little bit more powerful, so you can make your graphs more visually pleasing. So I'm going to have to learn that and get back to you on more of some of those cool things you can do with that. So as I open Sas Studio, what I'm going to do is just start writing a program. So it does take a little bit of a while to open. And then on here too, I created a data set in Google Sheets that I'll show you in a second. So as this opens, it's initializing. It just takes a little bit of time to warm up, and students will get used to that too. Just tell them if you're going to use this, it just takes a little while to connect to the web applet. So now on here, let me open up my Google Sheet that I did for that. So bear with me. Oops. So it's this untitled spreadsheet. I just did some example of height and weight data that you might want to put into SAS and run some data analysis on that. So first thing I'm going to do is give my program a title. So if I press in Shift 8 to do that star, what I'm going to do, everything after here is not commented in the program. So I'm going to write the name of my file. So file name, I'm just putting stats demo. Put written by, just say that I wrote this. And then a date. So today's date is 9/14/2021. And then what I'm going to do is put these lines there. It just deals with white space and shows a way of commenting programs and naming them. So the first thing that I'm going to do is run what's called a data step. So I'm writing data in here. If you notice, that turns in blue. Whenever you do a data step, you have to name the data. So I'm just going to call this stats data. Each line of SAS has to end in a semicolon. So I'm putting the semicolon. And I'm going to show you real quick from here how to just take your data and copy it and paste it. And I'm just going to have to add some things. Now, I discovered a little bit of kind of a glitch in how SAS runs on a computer and here. So in this data step, what I would do is input the variable for weight and height. So I'm going to put input. And then I'm just going to delete that. Those are the names of the two variables that I want. And then I'm going to put a semicolon here. Now, when I put the data in there, I just put that these are data lines. So this is typing in the data itself. At the end of the data, you have to put a semicolon. Now, when I copied it and pasted that, there's an extra space in there that creates an issue. So I have to go through here and delete that extra space. I'm looking through how I could open up a file with a Chromebook, but I have to find that out separately. So students could type in data lines if they wanted to. You just leave one space between each of the columns, and this would be my height, this column, and this would be my weight. Now, once I do that, I can click Run, and that will tell SAS this is the data. Now I could print this data. So a procedure step, you press proc, and then I'm capitalizing this for proc print. And then I put data equals, and I'm putting stats data. That just names my data set. And then to tell SAS to run, actually print that, you hit run and then a semicolon. So if I were to go here and click this little run icon, it will print that data set. So there are some other cool things that SAS can do. So here is an example of the means function. So I'm going to press procs means, and then I'm going to put again data equals stats data. And from there, I'm going to put in the things that I want. So I want the minimum Q1. the median. Oh, and here I put proc mean. I need proc means. That's why it wasn't lighting up. So median, the third quartile, and the max. And then what I'm going to do here is comment that. So this little asterisk tells it what I'm doing. So I'm finding the 5-number summary. Again, for large data, people use computers and don't compute that by hand. Now, what I need to do is tell it which variables do I want. So to do that, I'm going to put in height and weight. And then on there, I press semicolon and hit run. Now, some other things that it can do is find and draw a box plot. So to create a box plot, I'm going to go proc and then SG plot. And then from there, I'm going to use my data. Again, I have to tell it what data to use. So data is going to be the stats data. And on there, I just write on here VBox for the variable that I want the box plot of. And I can do the height. I can also do another VBox for a box plot of the weight. And then to make that execute, I just hit run. And then I'm going to comment too, so that I know in this part of this draws a box plot. And then to end the comment, I use a semicolon. And another thing that it can do is draw in a regression line. So I can put in here what's called proc SG plot. And proc SG plot, I need to put in the data. So data equals stats data. And then from there, this just draws a regression line. Now I have to remember to put that asterisk there, otherwise that would create an error. Get used to errors. If you're new to SAS, you will have lots of them. And just get used to tracing them out. So what I want to do is tell it, what do I want for my regression line? So I put reg to say it's a regression line. Then I need to say what I want on the x-axis and what I want on the y. So I'm going to put x equals height and y equals weight. Hit semicolon, and then again put in run, which SAS is not case sensitive, so I can put capital run or combinations of that, lowercase run. It will all work for that. Now I might want to find what is the correlation coefficient. So I can hit proc procedure for core, C-O-R-R. And again, always put in what data you want it to use. So data equals stats data. And for proc core, what this does is finds the Pearson correlation, or R. And I just have to say what variables I want. So I'm going to put variable is height and weight. And then again, after that command, I hit run to have that run. Now, what I can do is also create a scatter plot using proc core. So I'm going to do that in a separate line. I could have included that in this one up here, but proc core. And then again, data equals stats data. And on here, what I want to do is create a plots. So I hit plots equals and just a scatter plot. And then I just say what variables I want. So variables, I put height and weight. And this will just draw the scatter plot of the data for you. So if you're dealing with big data, you would not draw a scatter plot by hand. Chances are you'd use computer software like this to do so. And then here, let's say I wanted some regression. So what's my regression line? Is it significant? So you can do proc reg, which stands for regression. Again, you always put in what data you want SAS to use. And then our model. So the model here, my y variable, I'm going to put weight, is equal to the height. And then I would just click run here. And that's basically all I wanted to show you. So now I want to execute that program. So you hit the running man to run that. Now, if you have errors or if you made a problem, if you had a problem, you can go back to the log. It looks like I had one error. So I can go back here. It wasn't expecting an equal sign. So I can go back to the code and I can go back and look, where is my expecting an equal sign? And trace that out. So it is on here. If I look at the log, it is on the VBox one. So if I go back here, if you notice on here, looks like I can only do one of those at a time. So I'm going to take that out and hit run. And then go to my results. So here is when I printed the data set. If you look here, it's a proc means procedure. Here for height and weight is my minimum, first quartile, median, upper quartile, max. You can also do ranges. Here is my regression line of the scatter plot for height and weight. You can add labels to these too. There's ways to do that. Here on the proc core procedure is the correlation between height and weight. So if you notice, we have two of these listed. So you have a probability and a Pearson correlation. And then here is the scatter plot, which will show you from the proc core it ran what's my correlation coefficient. So there's a negative correlation, which if we look back at that line, the line is going down. It's a weak correlation because the points are not close to the regression line. So if we go back here, this will show you it has a p-value of 0.8198. A lower p-value would mean that it's more the points would be closer to the line. And then on here, when I ran the regression model, it will show you here's our model. The F value is 0.06. The probability of that is 0.8198. You want this to be closer to 0.05 or less for this to be significant. So my model is not significant. But what it can tell you is what would your regression equation slope and y-intercept be. So here's my y-intercept, 229.45. And then here is the height value, which is negative 0.75782. And then here are some other graphs that will be provided from the proc reg procedural. So you have like the residuals versus the predicted value. You have here a QQ plot or normal probability plot. You can also look at the histogram of the residuals and see if it resembles a normal distribution. So there are quite a lot of things that it draws for you. So I just wanted to show you that SAS is free, that you can use computer programming in context in your math classes to help kind of enhance what you do for statistics, but then also data is very big right now. I know if students go into data and were to take like a stats major or did applied statistics or anything like that, coming out of college, a lot of places are hiring data or statisticians at around 70 plus. So it's a huge booming career for kids. And there's a lot of free resources that you can use to enhance the technology in your classroom.